Hi, welcome. It is Tuesday, September 8th, week 7. And today we are going to do a review over the material in section 2.3. And tomorrow you'll have a 10-question quiz on this. So let's get started. Okay, the first thing that we did in 2.3 was we used the different signs from our trig circle here to determine what quadrant you were in based on the sign of the trig ratio, whether it was cosine, tangent, etc. So that's what we did first. And the way that we memorized this was using the acronym All Students Take Calculus. So all meant all of the functions are positive. Students stood for sine. So in the second quadrant, only the sine is positive. Take stood for tan. That means in the third quadrant, the only one that's positive is tangent. And the fourth one, calculus, stood for cosine, and that was the only one that was positive. So all students take calculus tells you which function is positive in that particular quadrant. All right, so on the review, the first couple of questions are doing just that. All right, so when you're doing these, you can obviously refer to this, or you got all students take calculus. All right, so the question's saying that cosine is greater than 0. So we know that cosine's going to be positive. And we also know that the tangent is positive. Okay, so cosine is positive in the fourth quadrant and in the first quadrant. So cosine's positive here and here. Okay, tangent, on the other hand, is positive in the third quadrant and the first quadrant. So the only one that is colored both is quadrant 1, which is our solution. Okay, number 2, cosecant. All right, so if we take our all students take calculus, all students take calculus, and it says the cosecant is positive. So cosecant is positive. So what that tells you is that the cosecant, that's the reciprocal of sine. So from this, we can conclude that sine is positive. Okay, so sine is positive 2 places. First quadrant, second quadrant. Okay, then we're told that the cosine is positive. Cosine is positive in the fourth quadrant and the first quadrant. So the only quadrant that is colored both is quadrant 1. Okay. Our next question deals with what we call the Pythagorean identities, and there was 3 of them. The one that we use the most often is the sine squared plus cosine squared of an angle is always equal to 1. And then there's these other 2 versions that we developed in our notes. Okay. So this next question is using the Pythagorean identity. It says, if you've got the sine squared of an angle plus the cosine of an angle that's squared, then that's going to equal 1. And there's your solution. That's just repeating the identity. Now down below, you're actually applying the identity. All right, the angle is 27 degrees. You're not using your calculator or anything. You don't need it, because if you're taking an angle and if you take the sine squared of 27 degrees and you take the cosine squared of 27 degrees, this identity right here tells you, doesn't matter what the angles are, as long as these two are the same, okay, which they are in this case, then that is going to equal 1. So it could be anything. I could have sine squared of pi over 6 as my angle, plus cosine squared of pi over 6, and I know that's going to be 1. I could have the sine of 0.7, the sine squared of 0.7 plus the cosine squared of 0.7, and that would equal 1. That's what this identity is telling us. Number 5, the angle theta is an acute angle and the sine of theta is 5/6. Use the Pythagorean identity, sine squared theta plus cosine squared theta to find cosine. So what we're going to do is just plug it into this top formula here. All right, so I know that sine is 5 over 6. So if I take the sine, whoops, clean that up. Okay, the sine of theta, so if I take my formula, sine squared theta plus cosine squared theta, that has to equal 1. All right, well, I know what sine theta is. It's 5 over 6. So I can take out this whole thing and replace it with 5 over 6. And now I want to square that. Plus now what this is going to allow me to do is to solve it. So I get 25 over 36. I'm going to subtract that from both sides. All right, now to do this subtraction, I have 1 take away. So I'm going to change that 1 so it has a denominator that's 36. So that's 1 with a denominator of 36. And then I'm going to subtract 25 over 36. And that gives me, let's see, 36 take away 25. That's 11 over 36. Right, now I want to get the cosine, so I'm going to take the square root of both sides. And I get the cosine of the angle. I can't take the square root of 11, but I can take the square root of 36. It's equal to 6. Okay, now here's where you have to be, let's see. Oh, that's all it's telling us, okay? So we don't have to worry about the quadrant on this one. So my answer is the square root of 11 over 6. You have to worry about the sign when you're given other information, like on problem 6. Okay, so on 6, we're going to do the exact same thing. All right, number 6 says find the exact value of the remaining 6 trig functions. And you're given the sign is 4/5, and theta is in quadrant 2. When we originally did these, we drew triangles like those. Okay, but now that you know about the Pythagorean identity, we can do it a lot quicker using the Pythagorean identity and understanding the signs based on the quadrants. All right, so the first thing here is when you're in quadrant 2, okay, so in quadrant 2, this is all students take calculus. And we're in quadrant 2 here. So in quadrant 2, the only one that's going to end up being positive is sine and its reciprocal. Okay, so the sine, this is positive right here. And then the reciprocal of sine, which is cosecant, that's going to be positive. The rest of these answers are going to be negative numbers. Okay, now what you do is you're going to set it up just like you set up number 5 using the Pythagorean identity. But now you're going to do it using 4/5 instead of 5/6. All right, so we're going to take our Pythagorean identity. So I'm going to take sine out and replace it with 4/5. So I'm going to have 4/5 squared so that gives me 16/25 when I square it. Then subtract 16/25 from both sides. Okay, so 1 take away 16/25. So I turn 1 into a fraction with 25 in it. And then I do this subtraction. And that gives me 9/25. Now to get the value of cosine, I'm going to take the square root of both sides. So there's my cosine. And since I am in the third quadrant, or second quadrant, that's going to be negative 3/5. And while I'm here, I'm just going to end up, I'll do secant, because that's the reciprocal. So that's 5/3. And cosecant is the reciprocal of sine, so that's 5/4. Okay, now to get my tangent, I'm going to use my reciprocal identity right here. Okay. Tangent is the same as sine divided by cosine. So tangent okay, now I know it's going to be negative, so I can just, I'm not going to worry about the negative right now. So let's see, sine was 4/5. and cosine is 3/5. And when I divide by 3/5, I multiply by 5/3. 5s will cancel, and I have 4/3. And that is my tangent. So that would be negative 4/3, and my cotangent would be negative 3/4. And there's our solution. So number 7, we can solve the same way. Use the Pythagorean identity to get, in this case, the sine, because you know the cosine. All right, and then use the quotient identity about tangent with the sine and the cosine, and you can get that value. Okay, so here's our steps. We're going to first determine our sines based on the quadrant that we're in. So in this case, we are in quadrant 3. So in quadrant 3, okay, we know all students take calculus. All right, so we got all are positive. Students, sine is positive. Take, tangent is positive. Calculus, cosine is positive. All right, we're in quadrant, it says that we're working in quadrant 3. All right, so I know because of that my sine is going to be negative, because the only thing that's positive there is tangent. My cosine is negative. My tangent is positive, and then our other sines, cosecant, which is the sine flipped. Okay, secant, which is the cosine flipped, and then cotangent. All right, so when we're filling these out, we got to keep that in mind. This is a negative, tangent is positive, cotangent positive, negative, negative. All right, now we're going to go and use our Pythagorean identity, and we're going to replace cosine with 7/25. Okay, now you don't have to replace it with negative 7/25, because when you square it, it's going to become positive. All right, so this was step 1 here. Okay, step 2. All right, so sine squared theta plus cosine squared theta is 1. And I'm going to take out the cosine and put 7/25. Even though it's negative, doesn't matter, because I've already figured out the signs. Okay, and now we solve this. Okay, so that takes there's step 2. We solved it and we got sine. Okay, we already know the cosine. And now we're going to use the quotient identity to get the tangent. So the tangent is going to equal the sine over the cosine. Okay, now we're ready to plug in our to get our reciprocals. There's my work for how I got the tangent. Okay, so now let's go up here. We know that sine is going to be negative, so it's 24 over 25. Our tangent is positive, it's 24 over 7. Our cotangent is that flipped. Our secant is the cosine flipped. And our cosecant is the sine flipped. And there's your solution. Okay, find the exact value of the remaining trig functions. Cosine theta is 1/2, tangent is negative. All right, so this is telling us that our cosine is positive. Okay, so cosine is positive in quadrant 1 and in quadrant 4. So I'm going to determine what quadrant I'm in. Cosine is positive in 1 and 4. Tangent is negative in 2 and 4. So the one that they're both colored is quadrant 4. So then you know what your signs are going to be. In quadrant 4, your sine is negative, your cosine is positive, your tangent is negative, and then your reciprocals, cosecant, secant, tangent, or cotangent, sorry, follows the same pattern. So minus plus minus, minus plus minus. Okay, now we're going to take our cosine, substitute it into our Pythagorean identity, and get sine. Okay, so now I know what my sine is. There's my work. Now I'm going to substitute that along with my cosine over here into my tangent formula to get tangent. So this is root 3 over 2 divided by cosine, which is 1/2. So that gives me root 3 over 1, which is simply root 3. So that's what my tangent is equal to. Oops. Now I'm going to take those 3 highlighted values, fill those in, making sure that I follow my rules here in terms of what's positive and negative. Okay, so my sine is going to be negative. My tangent is negative. My cotangent is going to be negative. Now when I have a negative root 3, the reciprocal of that is 1 over root 3, which I believe you have to rationalize, so I'll do that. And I get negative root 3 over 3. Okay, my secant is the cosine flipped, so that's 2 over 1, 2, and then my cosecant is my sine flipped, which is negative 2 over root 3, and that's got to get rationalized. And there's your solutions. All right, so now we're given both sine and cosine. So all we got to do is figure out what our signs are in terms of positives and negatives, and then we go right to the tangent, and then we fill in our reciprocal. So we don't need to use a Pythagorean identity on this problem. All right, so when we look at this, we know that the sine function is positive. Okay, so sine is positive in 2 and in 1. Okay, and then we know the cosine is negative. So cosine is negative in 2 and in 3. So the only one that's colored twice is quadrant 2. So that's where we're dealing with. We're in quadrant 2. So we know our sine positive, our cosine negative, our tangent negative, our cosecant, it's the same as sine, the secant, same as the cosine, and the cotangent, same as the tangent. Okay, now plug into our tangent formula here. Okay, our sine is 12 over 13. Our cosine, 5 over 13. I just ignore the negative because I've got this chart to tell me. So this is 12 over 13 times 13 over 5s. Okay, 13s cancel, and I get 5 over, or 12 over 5. And now I can fill in my values here. All right, cosecant is going to be positive, and I'm flipping my sign. Secant is going to be negative, and I'm going to flip my cosine. Okay, tangent we figured out was in that third quadrant, or no, second quadrant, tangent's negative. And cotangent is going to be that flipped. And there's your solutions. Okay, the next 3 questions deal with using these other identities, especially your reciprocal identities. Now, the point is this: when you take an expression and you multiply it by its reciprocal, okay, so for example, let's say I took sine of some angle, I don't know what doesn't matter, and I multiply it by its reciprocal, which is cosecant of the same angle, okay, a number or value times its reciprocal is always 1. As long as these two are the same. All right, so that means then cosine of an angle times the secant of the same angle is 1. And then the tangent of an angle times the cotangent of an angle of the same angle is also 1. Okay, all right, so for number 10 here, let's see, this one is using, this is the quotient identity. Okay, that's this guy right here. So what this allows me to do is I can rewrite that second fraction. I got tangent of 45 of 54 degrees, this is the same as the tangent of 54 degrees. And when I subtract those two, since they're the same, I'm going to get 0. Okay, number 11 uses the fact that if you take a function and multiply it by its reciprocal, and these two angles are the same, it's going to be 1. And then the same is true for 12. Okay, tangent and cotangent are reciprocals. These angles are the same. So if you multiply those out, you'd end up with 1. And that's what your quiz is going to look like. So the quiz will be on Wednesday. And good luck. And then I'll see you on Thursday. Take care, everybody. Everything's fine here.